Okay, so after I choose to share our addition strategies, we've been practicing them for a little bit. My curriculum naturally moves into subtraction of larger numbers. So just like with addition, we are going to start with number line strategies. However, I always surprise my students with the first one because it is called number line add up. Now you could certainly start with larger numbers than this if you want to. In my TPT store, you can head there and these are already made for you. But I do make these with my students. So the first day during our 10-minute math, right at the beginning of our math block, my students are always doing something in their math notebook to begin. So we start with 2 number line strategies. And so this is the problem that I have just chosen. Now add up, I do admit to them that my brain adds up to larger numbers much easier than it jumps back. So this is kind of a challenging strategy for some of them because they really want to start with this larger number, but we're actually going to begin with the smaller number today. So some of your striving learners who don't have a solid subtraction strategy, they're just doing the best they can with what they have, will appreciate that. So I'm going to tell them I start with a very small jump of just a plus 3. And I just ask them, why do you think I started with a plus 3? If I'm only at 40 and I want to get to 83. Usually they can tell me, well, that helps us because we're at the next tens. Some of mine will be able to mental math wise say, oh, I know what to add next. My suggestion to them is always to look at the tens place. Well, I'm in the 40s, but I want to get to the 80s. Hopefully somebody can tell me plus 40 will get me to that 80 mark. And then I want to get to 83. So we are going to do another small jump to get us to 83. Now, this is where it does get a little bit tricky because you need to ask them, okay, but where do we find our answer difference? And they're not always familiar with that word difference. So we have to talk through that accurate vocabulary of that the difference is what you call the answer to a subtraction problem. So if we already had 83, if we already have 37, we've got all of these numbers here, but hopefully somebody will suggest that we use these numbers, that if we do 40 plus 3 plus 3, that gets our answer of 46. Now, the other number line strategy that you are going to use, and again, I make this with my students during the first 10 minutes of our math block. I don't make the whole thing. Actually, the whole thing probably takes me about 2 weeks when it comes to subtraction. Anytime I'm working with larger numbers, then it takes me longer to get to that final strategy. So this one is going to be the one they're probably more familiar with, where we are going to subtract, where we are going to put, like I always ask them, how do I know on a number line, where do I put the numbers? Hopefully they know that you put the smaller number over here, the bigger number over here. So now you could make a bunch of jumps back. But again, I always tell them, put it into bite-sized chunks. So that first one I always do is a minus 3 to get me to 80, but I don't want to be at 80. I want to be in the 30s. But if I take away 50, that's going to put me at 30, and that's going to be way too small. So instead of going to 30, then I'm going to get close by hopping to the number 40. So that's where I always ask them, okay, what am I going to take away to start at 80? What do I minus to get to 40? Hopefully somebody can do the mental math and say a minus 40 will get me to 40. Okay, now I'm at 40, but I want to get to 37. Then I can do a minus 3 to get there. So again, we really have to be careful about, okay, we've got our 83, we've got our 37, but we've got a ton of numbers up here. Which ones do I use to actually get my answer difference? So again, hopefully they recognize up here is where you would do your 40 plus 3 plus 3 to get your answer of 46. Now, somebody usually always says something about, well, don't you think it's technically a minus 46? No, it's not, because I just put the subtraction sign up here so that we know which operation we are using. Okay, now with addition, this box was also break apart. So we are going to do a break apart strategy here. Again, in my classroom, anytime we use a break apart strategy, I always tell them and remind them of our rule. If you're going to break one number, the other number has to stay the same. So this is probably our first 2 to 3 days. That's all I allow them to do. Then I add in the break apart. And quite often, whatever we do for one practice problem, they are not allowed to use that strategy for the next one. But for their daily assignments, then they can use whichever strategy makes the most sense to them. Now, if I'm just introducing subtraction strategies, we're probably still practicing addition strategies. So with our break apart strategy, I asked them, with addition, I could choose either one. With subtraction, am I allowed to do that? The answer is no. I do have to start with that bigger number. So usually up here, then I will put the 83 takeaway, and then I tell them, oh, this will be easy because it's just an 83 takeaway 3. So do I just put my 80 here? Hopefully someone speaks up and says, no, the value of your 3 is 30. So you're going to do 83 takeaway 30 and get 53. But I noticed my answer difference doesn't match. So hopefully somebody will mention, well, you still have a 7 in the ones place. So we have to bring down our 53, take away the 7, and that is where you will end up with your 46. Now we will practice these 3 strategies again for at least a week to 10 days of lessons before I ever allow them to use an American algorithm for an assignment or for a class activity. The problem with this is some well-meaning parent, some well-meaning teacher has taught them how to do the process, but they don't always understand why they're doing what they're doing. So if there is a mistake or there's something inaccurate, they don't know how to fix it. So they're just repeating that process, and sometimes they repeat it correctly, sometimes they don't. So if this is the only strategy you've taught and you're just ready to throw everything out the window and you're frustrated, go back to these 3 strategies, which are more based in place value, and will give you a better understanding of where your students are at with actual subtraction. So it's a great day when I add this one to our chart and we can finally use it. Again, we get started where I ask them, where do we start? Because some of them will want to start in the tens place, which obviously with most American algorithms, you start in that ones place. But then I look at them and I say, oh, well, this is easy. 7 take away 3 is 4. But if I put a 4 in the ones place, that doesn't match our other answer differences. And somebody will usually speak up and say, nope, you got to borrow from the 8, cross it out, and make it a 7. But as soon as I ask why, that's usually where I get crickets. It's completely silent. They have no idea why they did that. So this is where you're really going to have to go heavy into, you take the 80, make it a 70. And yes, you are going to borrow a 10 next door, but then I'll mistakenly sometimes write a 10 up here. And hopefully someone will correct me that this needs to be a 13 because 10 plus 3 is 13. So we talked through that this 7 is a 70 plus 13 is 83. So no numbers magically went away. We just made them into 2 numbers that made our subtraction thinking easier. Now do we have the bigger number on top? Because that's always the first step I ask them is your bigger number on top? If not, that's when you know you need to borrow. So now can you do 13 take away 7, which you can, of course, that's your 6. And then I come here and I ask, well, why did we put that 7 up there? Is the value just a 7? No, technically it's a 70. Take away a 30, which if you put your 4 in your tens place, the value it represents will be that 40. But oftentimes they haven't been taught why they're doing what they're doing. And it annoys them at first, but again, it gives them a strong foundation in understanding why they're doing what they're doing.